Next up, we have Terry Brutzman from, she's a deputy CIO at the Naval Postgraduate School. And while she's getting hitched up, so the audio is right. We are going to try another experiment here. The team that is actually presenting to us is, I'll say, yeah, so is that going to work? Okay. I'll say is constrained by government restrictions right now, and it's unfortunate. Some of us that are working for the government are constrained on our ability to participate in conferences. And we're very pleased that the NPS folks submitted a paper for this conference, and very pleased that they can participate. But I think that all of you need to take this away and say, we need to be talking to some of our representatives and say, the participation of people like NPS is important, it's vibrant, it adds to the value of a conference like this, and so we need to get that message through to folks to say, bring pressure from all directions. In any case, what I'd like to do is introduce Terry. She's been in this position as the Deputy CIO for 2008, and she's filling in for this team, and we're going to have a neat little presentation here that hopefully works over
Google Hangout.
Google Hangout, right. And Terry's been a contributor to the educational environment at NPS since 2008. She has a background in cybersecurity and is expert in interpreting the governance to enable effective operations. She led their efforts in their cybersecurity inspection, where NPS passed with flying colors recently. She's supervised most of the major IT departments at NPS, has been engaged with CNIC since joining in 2004.
Thank you, Mark. So first, I just wanted to introduce the team since they fell off. So the three individuals, Juana Wells, she works in the Enterprise Information Systems Department and brought to this effort her knowledge of databases and API. And Greg Syme is the manager of the Network Operations Center, and he brought to the team the database and the knowledge of networks. And Terry Welliver is the Information System Security Manager, and I would say our lead person in the wiki and the JIRA. He's sort of the guru. Well, the team is really, and they have led us in our efforts in embracing this technology and helping us with tracking and project management. Just a little context about the cybersecurity inspection. It was done by the U.S. The Navy Cyber Command Office of Compliance. They held us to the criteria of a .mil network. We were all very nervous about this opportunity, and saw it as very important that we pass it. That we thought our EDU might be at risk, so we were very protective with that. This team was inspired to do this amazing work that you'll hear about, and we owe much of their work to our success and our ability to pass. So with that, I'll turn it over to the team. Oh, okay, I gotta do some.
Are we too loud?
Tell them that you can hear them.
We can hear you, and I'm trying to adjust down so that you're not so loud.
Nice. Okay.
Do another test. Can you test again? Nope, too low.
That happens. There we go.
Okay.
Hold on, we're going to figure it out.
Okay, try that. Just.
Yep.
You're very loud on this end.
That's okay. That's what we're going to get.
But we're good. Go ahead.
Okay, here we go. So give me a sec here while I bring up the presentation, and I think you should be able to see these slides. So I'm Terry Welliver. Like Terry said, I'm the Information System Security Manager, and we're going to talk about vulnerability management today. Please let me know if the slides don't come through. You'll have to tell me because I can't see.
They're good. We see them.
Okay, good. So vulnerability management. It's something that the Navy mandates us to do. It's best practice to do it, and it's kind of a hard problem to do. So I'm going to try and set the scene here and why we need to do this and our little problems and the solution we came up with. So first of all, just a few facts. The there's some good articles out there, but I mean, let's be honest, with vulnerabilities, there's always going to be bugs and holes in software, and people are always going to take advantage of them. It's just always going to happen. So it's like this cat and mouse game where we're trying to patch as fast as we can. The vendors are trying to release the fixes for these bugs, these things in the code that people take advantage of as fast as they can. But, you know, sometimes the fixes won't help you. If you don't know you have the bugs, right? If you don't know you're supposed to patch, we all run Windows Update and we update to Adobe Acrobat and all that, et cetera, et cetera. But you got to find these bugs. Some of the bugs are maybe the vendors don't even release a patch for it. It's a configuration issue. So when you apply the patches, you know, the fixes are usually disruptive. And you know, we want to be up 24/7. Our customers, they want to access resources whenever they need to access them. So patching actually gets in the way. And this is all like known. We already know this. And then I'm just going to mention here that, yeah, the Navy mandates it. We have to have a formal vulnerability scanning process in place. It's a best practice in the industry. You know, and we need to have one. Unfortunately, obviously we have budget constraints, right? Because we're all just sitting here doing this via Google Hangouts, and time is tight. People, sometimes manpower is an issue. So time and money is a big constraint that we have. So the typical solution, and this is a solution that I've seen in most bases I've been to, and you know, I haven't been to any other university, but I imagine it's kind of the same. You get yourself like a vulnerability scan, say like Retina or Nessus, NetSpark, or any kind of those things. You scan your network to find bugs. And the tool goes out, scans every IP, and then it gives you a report. And the report is limited to your administrator of the scanner, or your group of administrators. You look at it and you go, okay, these are all the actions I need to take on all these servers. Unfortunately, I'm not the person that actually can apply the fixes. I have to distribute these reports, and so what do? I go to my scanner, I export them as a PDF, and maybe I make a CSV, and then I email them to my various system administrators around the campus. And then I say, hey, you know, you guys need to fix all these findings. You need to track them. You need to tell me which ones you can apply the fix to and which ones you can't, if this is a false positive, et cetera, et cetera. So I create another Excel spreadsheet because I got to send this out to like 10 people, and you know, they're able to apply the fixes. I track that they got the report to do the fixes, and then they send me their Excel spreadsheet back saying, hey, look, please make sure that we've applied these right. So what do? I just rescan and start all over again and just repeat the process. Okay, so let me show you how this works here on our network. This is what our network looks like here at NPS. You have the internet, you have our perimeter, our border router, all that good stuff. And then we have a DMZ at NPS here, and an internal network. And so the network is like this simple with like 10 systems. That spreadsheet solution totally works. It's totally fine. It's great. No issues at all. Email works great. However, I can show you the real diagram that we have for our network, but the Navy doesn't let me do that. So our network actually looks exactly like this. And the internal network has like hundreds of systems, hundreds of servers, and the DMZ has hundreds of servers. So now that I can't count all the systems on two hands, the tracking of all these vulnerabilities is like a nightmare, right? Again, I think I probably could buy something that probably fixes this for me, but resources are tight, so I can't buy anything. So this solution here that we saw, that we came up with, is actually still a problem. It's a different problem though. I mean, we can scan and find the vulnerabilities, but it's a different problem. So you have to think about it a little differently. So our solution that we came up with is we realized that, hey, look, we need a scanner. Right? Everybody needs scanners. We got to find them. And instead of using spreadsheets, let's stick everything, all the results into a database. Because that makes more sense. We can do more things with it in a database. And then, you know, we're going to go and say, hey, look, instead of distributing this stuff via email, let's put it all on a web page. And then let's restrict the web page down to only the people that need to see the information. So if I'm the system administrator for system X, I get my own web page with all my findings on it that I need to address. The next system administrator for system Y, same thing, he gets his own, but he can't see system X or system Y. Kind of makes sense a little bit. Unfortunately, we ran into another issue when we started doing this, and that was that our web designers and developers, they're kind of busy people. So they really couldn't dedicate any resources to us. And so we kind of looked at the problem again, and then we said, well, what we really need is not just a website, we need to track issues. Okay, we need to track things. Vulnerabilities are just things that I need to track. There's quite a few of them. Potentially, I don't know, 100 per system or so, right? Maybe, could up to that much. So we need an issue tracking system. All right, so then here's what we ended up with. We used the Retina scanner, and did it change yet? Yeah, there it goes. We used the Retina scanner. That's mandated by Navy, and that's changing to NESIS here soon, but Retina, we're stuck with it, so that's what we used. We picked for our database, we picked Postgres, and we picked that because it has some native data types that we really like. It really supports IP stuff much better than a regular database does. And then we picked JIRA. Now JIRA is made by Atlassian, and it's an issue tracking system. It was actually developed to track software, to develop software. So it's software to develop software. But we thought it'd be a great choice here because it tracks lots of things and it tracks it really well. So then we looked at this is what we had, and we said, look, we can tie it together with some Ruby scripts. And I'm actually not the Ruby script guy. Greg is, so Greg can talk about what we do there.
Yeah. So really this started from Retina, looking at, we have all these reports, and the slowest part about Retina, just an idiosyncrasy of that system, is that it takes longer for Retina to generate the report for a single system than it does for it to scan the entire subnet. So you get all this information, and you can put it on a schedule. It'll scan and gather all this information together, and then it puts it all into an RTD file, which is a non-usable file extension. It's a Retina specific. What it turns out to be is a MDB, so transactional SQL database file, but they hide that under a different file extension name and generate each report per Terry's method, the old spreadsheet email reporting system. That was the longest part of the process. Using Ruby scripts, using some of the publicly available gems, we were able to take those RTD files, convert them to MDB, which is now recognized as a transactional SQL database, read that database, and push that data into the Postgres database. So we actually have 3 servers on the network that do scanning. Each of those 3 servers has an instance of the Ruby script that will read the RTD files as they're generated by Retina and push that data to Postgres, which is all on one single server. And this is, again, just open source gems, which is the module or packages used by Ruby to allow for the connection from transactional SQL. We push all the data into a temporary store appropriate per the result that it is. So each system, each vulnerability gets brought in one vulnerability at a time and then pushed over to the database. In Postgres, we take advantage of, as Terry said, the IP address data type and the MAC address data type that allows us to track each system not only by its presence on the network, but then also its NIC. So making sure that we are tracking a single piece of hardware as a single IP address, and that a sysadmin who has something that has moved doesn't end up with multiple issues tracking the same vulnerabilities for the same system across 4 or 5 places, which that becomes more of an issue when you're dealing with wireless or just something in the DHCP space. Primarily the focus here is servers, which don't move around that much. So all of that feeds into Postgres, and then movement from our Postgres database to JIRA, that is WANA.
Yeah, so just to mention it real quick, we chose JIRA because JIRA has an extensive API as well. And WANA is like our API guru. So she takes everything that Greg puts in Postgres and does some magic and puts it into JIRA. So why don't you talk a little bit about?
So that's exactly what I do. I take data, normalized data in this case, that sits in our Postgres database, and then I basically use public libraries such as the JIRA client and the JIRA REST Perl libraries, and figure out how I could push this data essentially to the JIRA project dedicated to tracking these kind of scans. While we're building or using these libraries, we're also creating our own libraries where the way that the code is structured, essentially it allows you to reuse that same data for many other projects that we have chosen that needs automation. So based on the requirements that Terry has given, I'm able to essentially just use the JIRA API, both the SOAP API and the REST API, to push this data in a timely manner as the data gets put into the Postgres database into JIRA, and then of course, manipulate statuses on each of these findings so that the system administrator is aware of the scan results for their servers.
So let's talk about, I just want to take a minute here and talk about JIRA and some more features we get from JIRA. So Greg takes it from Retina, pushes it into Postgres, processes it, and then WANA looks at the data and then puts it into JIRA. And if you haven't seen JIRA, you should really check it out because it'll change your world, be serious. But JIRA has a couple features that we really liked. It has a user interface because none of us in this room here we're not our front-end designers. But the JIRA user interface, pretty much everybody gets it by going to a JIRA issue, and then they're able to understand what they need to do. So it's really easy to use. And then we get this thing called workflow. And workflow is very, very, very powerful. You can do lots of stuff with workflow, and all you need to think about workflow, what it is a flow chart. Okay? You get a ticket, it's in some state, you move it to another state. Why is it there? Here's why it's here. Move it to another state. And each time you transition, you can do things automatically. So WANA has a bunch of scripts that run, or she uses the JIRA API to execute certain actions as issues transition from state to state. What else do we get from JIRA? We get automatic notifications and accountability. So we get the permission side already taken care of for us. We set the permissions on the JIRA project itself, and then it takes care of everything else for us. We don't have to dynamically set that. Documentation. So this kind of came late for us. We always need to document, accepting risk, because I can't actually patch everything that needs to be patched. I can't actually apply every fix that that needs to be fixed on a system, because it might break mission, it might break the functionality of the system. So because JIRA is set up as a ticketing system, and we're pushing in one vulnerability or one finding per issue in JIRA, a system administrator can say, hey, I'm not going to fix this finding because of X, Y, Z. And then we can have a discussion, and all of a sudden we have our automatic documentation. We don't have to do anything additional. Then what else do I need? It tracks everything, which is going to help us in some future work here that I'm going to talk about in a second. And then we're able to, using workflow, provide feedback and push data from JIRA back into our Postgres database. And that means that our Postgres database is our master database of all the systems, all the points of contact, all the findings. And that's our big dog, is that Postgres database. JIRA is merely the front end that we use to interact with our system administrators and the system itself. And so that's the system in like a nutshell. It was really hard to write these slides because you had 20 minutes to present, and not sure how to make it simple enough so that somebody can understand it, and I hope we're able to kind of do that. We can actually show an example here in a little bit of the system, but before I do that, I just want to talk about where we're going with this. Greg's going to have to do some work here because Nessus is going to replace Retina, and Nessus actually has an API that we might be able to tap into. So it might make this process a little bit easier for us. But that has to be redone here, and we're working on that right now. And then global risk acceptance is definitely on the list. And what this is at a holistic level, identify false positives across the board, right? So system administrators out there managing Linux systems go, hey, this doesn't apply, Red Hat has backported this, et cetera, and we start seeing it across all our servers where you go, you know what, at the database level, let's accept this risk, let's mark it as false positive, let's mark it as a won't fix globally, and then the system administrator doesn't have to do anything. They don't even get the finding anymore. What else? Automation. We're going to automate everything we can. Our cybersecurity team here is pretty small. We're all hurting for resources, and the business is asking, the campus is asking for more functionality, which means that we have more systems, more vulnerabilities. So we got to figure out how to patch faster and better. The delicious cake, because when that's done, we're going to take a break a little bit and see and watch it work for a little bit, and then we'll figure out what's next. But that's pretty much concludes the presentation. I can show a quick example of what it actually looks like in JIRA if you'd like, Terry.
Yeah, that would be nice.
Yeah, cool. So, because we're right at the 20 minutes here, and I don't want to go too far over.
Okay, you have 2 minutes.
2 minutes, I got 2 minutes. Sweet, so I've already got one loaded up here. Sorry, this is going to take a second for it to come through there. So this is a JIRA issue. So this is so you're not seeing real data here. We've cleaned all this data. But so this is what we did is JIRA works on issues. You have an issue is a container for a scan, and then you have subtasks, which are still issues for each system. So what's happening here is down here are the actual findings. So you're looking at a system level on this screen. So this system's called Peridot. It has an IP. It looks like it's a Red Hat server. Belongs to one of Wells here. It's hers. And we have a workflow that it goes through. And the workflow is literally just, we create it from the Postgres database, and then it gets resolved. It gets resolved when all the findings have been fixed and the system automatically resolves it itself. So this gets assigned to the system administrator, one of Wells in this case. And if I clicked one of these findings down here, I've already got it loaded to save time. This is what a finding looks like. So it gives you a severity category, what kind of scanner gave it to you, finding ID, and then it keeps going down and tells you actually how to fix it. This is really important because in the past we give somebody a spreadsheet and say, hey, here's this finding ID, you need to fix it, and then we give them a PDF and say, hey, cross-reference on this PDF, and then go fix it. Well, now we're putting all that data right in front of the individual. So then at this point, they can actually fix this by getting fixed, false positive, or won't fix. This is the workflow. And then at any time, we can comment and have a discussion between the system administrator and the security staff at NPS, or the network staff at NPS, all without having to be an email. And so this is pretty much the basics, and that's pretty much all I have. We can take questions, Terry, if you want, or we're standing by. You're in the room. I don't know what's going on now over there.
Sure, thank you.
So confused looks? Probably confused looks.
Not a lot of confused looks. We're basically out of time, but I would entertain at least a question or two if somebody had a question for these folks. Okay, it doesn't. There's no hands raised. I guess you stunned the crowd. We'd really like to thank the team of three there, also for coming up with the great concept to try out Google Hangouts on this crowd. And I'd like to, in particular, thank Juana, Terry, Greg, and Terry. Let's give them a big round of applause.